Hello and welcome to the 1.04 Physical and Chemical Properties screencast. This is the first in a 3-video series. Again, I'm Mrs. Willie and here we go. Properties are characteristics of pure substances. So if you remember back to lesson 1.03, that is anything that is an atom, a molecule, or a formula unit that is a constant composition. So a sample that is all atoms that are the same, all formula units that are the same, or all molecules that are the same. Properties of matter fit into two categories, physical and chemical. Physical properties are observed without changing the chemical bonds. So stirring, evaporating, boiling, filtering, those are all ways we can observe physical properties. Chemical properties are observed when a substance interacts with another substance or when chemical bonds break and or form, or both. Physical properties can be split into two subcategories, intensive and extensive. Intensive do not depend on the amount of matter present, which means it doesn't matter if I have 5 grams of ice or 500 grams of ice. This property will stay the same about ice. Can be used to identify a substance. Most physical properties can be classified as intensive. Extensive depend on how much matter is present in the same sample. Any properties whose value changes with changes in mass, volume, length, or the number of particles. So, examples of intensive properties are color, odor, texture, melting point, boiling point, freezing point. So anything that you use your senses to observe. So I'm making qualitative and quantitative measurements here, but I'm using my senses to do so. The state of matter, solid, liquid, and gas, that doesn't change no matter how much I have present. Luster, or the shine of an object. Malleability, which means that the substance is got the ability to be beaten into thin sheets. Ductility is the ability for a substance to be drawn through a wire. These three last characteristics are usually characteristics of metals. Conductivity is the ability of a substance to permit flow of thermal energy. And the unit for conductivity is S/M. Some more examples would be density, which is the mass of a pure substance per milliliter or per centimeter cubed. This doesn't change. That's why it is intensive. So going back to my last example, so density, the density of ice is going to be the same whether I have 5 grams of that ice or if I have 500 grams of that ice. The density of liquid water would be the same whether I have 5 milliliters or 500 milliliters. And the density of gaseous water or vapor would be the same whether I have 5 liters or 500 liters of that gas. Molarity or concentration, its units are moles per liter. And I know you don't know, most of you don't know what that is, but don't worry, we will get there in the next unit. It could also stand for the number of particles per liter of aqueous solution. So if I have an aqueous solution of salt and water, it would be how many particles of the salt do I have per liter of the water in the solution. Molar mass, which is grams per mole, the mass of 1 mole of a pure substance. So again, it's okay if you don't know what that is. We will talk about it and be more in depth in the next unit. Specific gravity, which is the density of a pure substance compared to the density of water. We use this a lot here on Earth. Specific heat, heat required to raise the temp of 1 gram of substance by 1 degree Celsius. So how much energy basically is required to heat 1 gram of, let's say, copper by 1 degree Celsius. And that the units for that would be joules per grams times degrees C. pH, which is the measure of hydrogen ion concentration. Temperature could be in degrees Celsius, or Kelvin, which is the average kinetic energy of a sample. And this is a tricky one because I know why is this put in intensive? It's because, let's go back to our water example. If I have 5 grams of ice or 500 grams of ice, what I know about water is, or H2O is, that no matter what, at 0 degrees Celsius, I will have a solid state of ice. At 100 degrees Celsius, I will be going from a liquid to a gas. So temperature is intensive because if at -10, I know that my sample will be ice. If at 40 degrees Celsius, I know my sample will be a liquid. If at 120 degrees Celsius, I know my sample would be gas. So that's why it is an intensive property. Extensive physical properties are mass, or the amount of matter in a sample. I take my ice over to the balance and I measure the mass. It is got a unit of grams. Length, the extent of matter along its longest dimension, and that's usually taken in meters or centimeters or millimeters. The gravitational force of attraction of the Earth acting on a sample would be the weight. That is used here on Earth. We use weight all of the time because we have gravity. Volume, amount of space occupied by a sample. That's the unit of liters. Or area, you can also use centimeter cubed. Number of moles, the number of particles, atoms, ions, formula units, or molecules in a sample. Again, we'll talk about moles next unit, but I want to go back. So now that I've talked about extensive properties, so these all change with the amount of matter I have present. So mass, back to my water example, 5 grams is very different than 500 grams. That's why it's an extensive property. It changes. So same with volume, same with length. The length of 5 grams of ice is going to be very different than the length of 500 grams of ice. The number of particles in my saltwater solution, it could be very different and would be very different between a small sample in a glass compared to the ocean. So I want to come back to the intensive properties now that I've introduced extensive properties, and talk about this note at the top that says a property that is defined by a ratio where 2 or more quantities. So that means I'm taking 2 extensive physical properties and I'm comparing them and putting them into a ratio, which means I'm dividing them, is intensive, since these ratios do not change no matter how much matter is present. So anytime I see a ratio in units of extensive properties, I can assume that that is going to be an intensive property, because it will not change no matter those ratios. Like I have a small with a large, or a small and a small, and a large and a large. So the ratio will always stay the same. Chemical properties. Compounds are the only class of matter that can be separated into elements by chemical changes. So molecules and formula units. Molecules, chemical bonds break into individual atoms, and formula units, chemical bonds break into individual ions. The individual atoms from the molecule interact with other individual atoms, or with the individual ions, and the individual ions interact with each other or the individual atoms. A chemical reaction occurs, and different molecules or formula units are formed by new chemical bonds. So if you look at my picture down here, I have 2 variable elements in my molecule, and then I have 2 constant, or the same consistent variable in the second molecule. They interact with each other and form 2 new variable or different elements in those molecules. So bonds have been broken and bonds have been reformed. Chemical properties example, and this is only a visual at the top. This is not a balanced chemical equation. We'll be doing that in the next unit as well. So if I'm looking at physical properties, so I can look at iron, I can look at oxygen as they are separately. I can put them together. A chemical change or chemical reaction occurs, and I create iron 3 oxide. So iron by itself is a shiny gray, lustrous, conductive, malleable, ductile element because it is a metal. And then oxygen is a clear, colorless, odorless gas. It is a nonmetal. I react them in a chamber together and they create iron 3 oxide, which is a solid that is red. It is not lustrous, conductive, malleable, or ductile. And as I can see, I've gone from an atom and a molecule to a formula unit. The melting point of iron is really high because that is a characteristic property of metals, is they have high melting points. The melting point of oxygen is really low because that's a characteristic of the melting points of gases. But the melting point of iron oxide is even higher, which is kind of surprising. But if I know that ionic bonds, which is what's happening here, is very strong, then I can understand why that melting point is so high. The molar mass of iron, which is the amount of particles per mole of iron, 55.845, so fairly dense and a solid. Oxygen, much lighter, 31.998, a gas. And then I react them and I have a much denser formula unit. So therefore, this would also be a solid, 159.69. Iron was magnetic, oxygen was not. When I combine them, it is not either. So this is an example of showing what happens during a chemical change or reaction. So I can say that they were reactive. The chemical properties were reactive. So the ability to react or not react is a chemical property. Iron and oxygen formed iron oxide. That was the ability to react. Now I could test to see, does it have the ability to oxidize or corrode, which means will it tarnish, rust, or decompose or not? Does it have the ability to burn, which is combustion or flammable, or not? So I would have to do those tests on it separately, which are also chemical changes in themselves. Thank you for watching this first video.